Hi, welcome back. So before the break, we were talking about the proofs of the three trigonometry rules. We've already done the area rule, and now we're going to do the proofs of the sine rule and then the cosine rule. They're pretty simple, and we start off basically very similar to how we start off the area rule proof. Let's go. So, can you remember about what is the sine rule? Okay, the sine rule says sine A over A is equal to sine B over B equals to sine C over C. And the reciprocal version, A over sine A equals to B over sine B equals to C over sine B, C over sine C. So we're going to start off with proving just one of them, and then the other we can deduce from our first proof. Okay, and can you remember when we use the sine rule? Just to try and recap quickly, we use the sine rule when we have one full pair of opposite sides and angles. Okay, so when we begin this construction, we're going to begin this construction exactly as we began the construction for the area rule. And that means we are going to be doing a construction, and we're going to construct h, the altitude, again from the same place that we did earlier, and we're going to construct it from vertex C again. So we take our pens and we draw a straight line from C down onto AB. Let's call this point D. And this is our height. Okay, so this is our height of our triangle. And we're going to now continue our proof. So once we've done that construction, that's the first step of our proof. Okay, now if we look at triangle ACD, which is this triangle here, ACD, this triangle here. If I try and write out a formula for sine of A, similar to earlier, it's going to be opposite over hypotenuse. So it's going to be H over B. And then we're just going to rearrange this to make H the subject of our formula, and we're going to end up with H is equal to B times sine A, because we've just multiplied throughout by the B. Right, now we're going to look at the other triangle, this triangle on this side, so BCD. So in triangle BCD, we're now going to make a formula, we're going to write out the value for B, sine of B. And sine of B is going to be, now that's the opposite, but in this triangle, this is going to be the hypotenuse. So sine of B will be H over A. So let's write that down quickly. It's going to be H over A. Now, we're going to just rearrange that again, just to make H the subject of our formula, and we're going to end up with H is equal to A sine B. Now, where are we going with this proof? So we've got two different equations that both equal to H. So what we can do now is equate both right-hand sides together. So we can equate B times sine A with A times sine B, because they're both equaling H. And we can now construct a new equation that looks like this. Okay, so B times sine A is equal to A times sine B. Pretty simple. We just found out sine of A, we found out sine of B, we made H the subject of the formula, and now we're equating both right-hand sides. The next part of our proof is really simple. Okay, so once we have this equation, okay, we're now going to divide both sides by AB. So I'm going to divide this side by AB, and I'm going to divide this side by AB. And what's going to happen now, can you see what's going to cancel out? Okay, so now on this side, the B's are going to cancel out, and on this side, the A's are going to cancel out, leaving us on the left-hand side with just sine A over A. And on the right-hand side, in the numerator, we're left with sine B over B. And that's exactly what we needed to prove. Sine A over A is equal to sine B over B. Right, so how do we prove the other versions of it? We can just draw a different altitude, so we can just use the word similarly, and say similarly, if we do an altitude from B, we can do the exact same proof, and we can prove that sine A over A is equal to sine C over C. And if we drew the altitude from A, we can prove that sine B over B is equal to sine C over C. So basically what we've just done now is we've proved the entire sine rule. We've proved that sine A over A equals to sine B over B, and that's equal to sine C over C, so they all three have to be equal to each other. And remember, from this we can conclude the reciprocal version by just swapping that around. Okay, so that was the sine rule proof. Not too bad. Now we're going to do the cos rule proof, which works around the same lines that we just did the area and the sine rule proof. We actually start off in almost exactly the same way again. Let's begin. Okay, so what is the cosine rule? Remember, a squared plus b squared minus 2bc cos A. B squared equals a squared plus c squared minus 2ac cos B. And the last one, c squared equals a squared plus b squared minus 2ab cos of C. Okay, and again, exactly like we did before, we're going to start off with our construction. So let's construct our height again. We're constructing a height again from vertex C. So we're drawing our height perpendicular to our base. There's our base there. And our height, we're going to label it h. Okay. Right. Again, we're going to just start writing out a formula for sine of A. And sine of A will equal to, this is sine A, so opposite, over hypotenuse. So it's h over b. And again, we're going to make h the subject of the formula by multiplying throughout by b. So h will equal to b sine of A. Right. Now we're going to do something slightly different because we want to introduce the cos. Because it's a cosine rule, we're going to find cos of A. So cos of A is now going to be in this triangle, because remember we're working with triangle ACD, it's going to be this side, adjacent, this side here, over the hypotenuse. So cos of A will be AD over our hypotenuse, which is B. Remember, in this case, we're working in triangle ACD. So we're working in this triangle. So in this triangle, if I want to find the cos of A, it's adjacent, that side, okay, which is AD, over my hypotenuse, which is B. Okay, now we're going to just rearrange this again, and we're going to make AD the subject of the formula. So AD will equal to B times cos A. We've just multiplied the previous line by B. Okay, but we have to realize something. If we're finding out BD, if I need to find an expression for BD, because this whole piece here is C, let me just grab another color. Because this whole piece here is C, if I wanted to write BD in terms of C, this little piece from here to here will basically be C minus AD. So I'm going to write BD as C minus AD. This will help us with our proof, as you'll see in just a minute. Okay, so we've got an expression for H, and we have an expression now for BD, and we have an expression for AD. Okay. Okay, so BD was equal to C minus AD. Let's continue. Okay, sorry, there was something that I forgot to write in here. Okay, sorry, so B was equal to C minus AD. But remember, we had this expression for AD, which we now needed to substitute in here. So BD was equal to C minus, and whatever we had for AD, I'm going to substitute in here. So instead of AD, I'm going to put this piece of the equation is here. So it's going to be C minus B cos A. Okay, so now we have an expression for BD that includes C and cos of A. Okay, so just to remind ourselves what we had on the previous slide, we had an expression for H, and we had just made an expression for BD. Okay, now if we look at this triangle here in BCD, so this triangle BCD, we're going to use Pythagoras. And if we use Pythagoras, we know that the hypotenuse squared, so A squared must equal to this side squared, so BD squared, plus H squared. And that's just using theorem of Pythagoras, which we're quite comfortable with using for a while. Now, the reason we're using Pythagoras is because we want to, remember, we want to prove something about A squared is equal to B squared plus C squared minus 2BC cos A. Okay, so we're going to now substitute each of these. So for BD, we're going to substitute this in. And for this H here, we're going to substitute this in. Okay, so A squared is equal to C minus B cos of A. Okay, that's from here. And from H squared, we're going to say B times sine of A. Okay, now we just have to square these binomials. And if you remember our rules for squaring a binomial, let me just get rid of this extra mark we have here. Okay, now how do we square a binomial? We start off on this side. It will become C squared minus, if you multiply the 2 and double it, it's 2BC cos A. Our third term will be squaring this term here. So it will be plus B squared and cos squared A. And now we're going to square this one term here. It's a single term, so we just got to square it. So it will be B squared sine squared A. Right, now if you notice, we've got a B squared here and we've got a B squared here. So we're going to try and take out a common factor from these two terms. Okay, so here's it written slightly neater. A squared is equal to C squared minus 2BC cos A plus B squared. So we're going to take out B squared as a common factor. We'll be left with this cos squared A, okay, plus this piece here, which is sine squared A. Now, look at this middle piece in our bracket, and what do you notice about this? This reminds us of the identity that says cos squared plus sine squared equals 1. Okay, and we know the trigonometry identity from grade 10. So we substitute that for 1. And now we have something that looks almost exactly like what I want. So what did I want? A squared is equal to B squared plus C squared minus 2BC cos A. So what remains is just to rewrite this in the right order, putting that in front. And we end up with A squared is equal to, let's write that quickly, B squared plus C squared minus 2BC cos of A. So now we've proved the first version, and again, similarly, if we just change where we start drawing our height, we can prove the second version. B squared is equal to A squared plus C squared minus 2AC cos B. And similarly, if we move the height in from a different vertex again, we can then prove this third version, which is C squared equals A squared plus B squared minus 2AB cos C. And that concludes all three proofs now.